Hello, I'm Minaz Merali, Program Director for IBM Z DevOps. This is a short demonstration of how you can use CI/CD practices, common tools, and a collaborative coding environment to bridge the gap between mainframe and other platforms. We have a banking and insurance application that we voice-enabled using the power of REST API services running on IBM Z with IMS, KICS, and DB2 subsystems. However, when I ask this application about the state of my car insurance policy, it's not able to give me the information that I need. Let me show you what I mean. Computer, ask IBM Z how long until my car insurance expires.
Your car policy for your car expires on January 1st, 1999.
So it's telling me that my car insurance policy expires in 1999, which is a red flag right there. So a change needs to be made. And I'm going to demonstrate the implementation of this change from getting that change coded, pushed into GitHub, automatically tested, and then sent off into a pre-production environment. What you see here is the Z Open Development environment, which provides build and IDE capabilities and allows you to seamlessly interact with Git. Clone in your Git repositories, interact with your ZOS, your mainframe systems, and provides the capability to build the ZOS code stored in Git. Git, of course, being the de facto standard for source control in application development. You can see that I've connected into GitHub, and there's an enhancement request raised for a change in a ZOS application program. And I'm going to demonstrate how this change travels through the various stages. As we're using Git as the SCM, I can carry out true parallel development. And I'll make sure that I isolate my changes and create a new branch. I name my branch expiry feature, and I proceed to make my changes. And again, I'm doing this within my branch that I just created. Branching is really core to working in Git, and it's powerful because it allows developers to work in lots of different isolated environments with small units of change without impacting the work of others. So I make my changes in a COBOL program. I then proceed to initiate a dependency-based user build, which builds this program in my own PDSs. And now you can see that my user build is complete. What you also see is that I've run some unit tests along with the build. I have a KICS program, and I've unit tested it by stubbing out all KICS statements, and I did all this before even checking in my code. Now, since my user builds and unit testing was successful, I'd like to move my changes to the next phase of integration and other tests. So I commit my changes to the new branch, make a note of the expiry date changes that I made. And next what I'll do is raise a pull request, which is really asking permission to merge my change code into an integration or master branch. I also associate this pull request with the issue that's related to the change that I made. And I let the team know of the changes that were made, and I then go ahead and create the pull request. When I initiate the pull request, it automatically assigned code reviewers and also kicked off a Jenkins pipeline, which ensures that the changes that I checked in are all built and taken through a level of initial tests. And these are important quality gates to ensure that any defects are caught earlier in the development lifecycle. And this pipeline runs on a personal ZDNT, providing the isolation needed to test my changes. Now, when I got added as a reviewer, I got an automated email that I need to review a code change. And before I review, I check that the pipeline has run successfully. And you can see the green check mark there from Jenkins, but a red cross saying that the code owner is still required to review this change. So as the reviewer, I'm going to go in and I review the changes on the left. I'm going to leave a general summary that the changes look good to me. Add in a little picture of a ship to say that I want to ship it, and I'm then going to approve this and submit my review. As soon as I click on Submit Review, we're going to see that all those changes have been approved and everything is green. And now when we switch back to the developer view, I'm able to go on in, see that my pull request has been approved, see the full review history, and all the conversation that occurred around this change. I can then go ahead and merge the pull request after making a note of the issue that I fixed, in this case issue number 9. And by confirming this merge, what it also does is it closes out the issue that was opened, which has now been addressed. What the merge also does is it kicks off a detailed pipeline that runs on IBM Z. And you can see that this pipeline includes a build, automated unit tests, quality check with SonarQube, deployment with Urban Code, and runs integration tests for the CICS and IMS APIs. While it runs the integration test, in parallel, it's also monitoring performance of the system and providing a report at the end, letting us know if there are any performance issues in the code. So we've seen how the change moved through the automated CI/CD pipeline, and finally it gives us a report on Slack, which notifies us if our build has been successful. So now that I've made the code change, let's put our voice-enabled application to the test again. Computer, ask IBM Z how long until my car insurance expires.
Your car policy for your car expires on March 1st, 2019.
And we can see that the voice-enabled application is now providing the right response, which means the change was successfully implemented. And that brings me to the end of my demonstration.